Howdy ho, students. Coming at you with applications of the Pythagorean Theorem. It's time for old dead Greek dude times. Okay. The Pythagorean Theorem, of course, is a squared plus b squared equals c squared. And it helps us anytime we have a right triangle or even a non-right triangle that we can turn into a right triangle in order to solve for a missing length. Okay. This is the basis of trigonometry. This is the basis of a lot of our engineering, the fact that we can create these accurate measurements. Okay, now this here is one of our perfect Pythagoreans, okay, Pythagorean triplets. 3, 4, and 5 are really well known because they just work out so perfectly. A lot of times when you're doing a Pythagorean theorem, it doesn't come out to a whole number. Over here, though, 3 squared plus 4 squared equals 5 squared. And remember, what I've said before is sometimes you want to, you remember that if you have, two sides of the equal sign, you might want to be like, hey, why can't I just square root both sides first and then find my answer? And the reason why you can't do it here is because technically you cannot square root this until after you've added those together. Okay, the math just does not work out. This, the square root of 3 plus the square root of 4, okay, these are very, very different problems, okay? They give you very, very different solutions. And because that plus sign is there, everything gets very confused. You can't do that. If you had 3 times 4, okay, and they were both squared, now you have more, you can do more things, right? Because what you essentially have here is 3 times 3 times 4 times 4, okay? That's very different than 3 times 3 plus 4 times 4. And so the things you can do with them is different. So I just want to really make sure you remember that you cannot square root these until after you have done the math, okay? After you've solved that addition. So in order to solve this addition, I have to actually do 3 times 3 is 9, plus 4 times 4 is 16, okay? Now I want to square root that to get my answer of 5 or whatever is over here, because I can solve this one right ahead. I can just go ahead and make it 5. But this one I can't do until I add those together. So now I have square root of 25 equals 5, and that one is going to be 5 equals 5, which is correct, right? But if I had tried to do that before, if I had ended up doing 3 plus 4 equals 5, I got some news for you guys. That doesn't work. 7 does not equal 5. Okay. All right, some of the classic triplets are over here. Now, the cool thing about these triplets is if you remember them, they're going to show up over and over again in your math because the math books actually, they don't want to be jerks. They don't want to be too difficult. So they're going to do everything they can to give you whole numbers so that you know that your answer is correct. Okay. All right. So let's go over to these actual works. Before pouring concrete foundation for a building, construction workers build wooden frames to hold the concrete. Then a worker or building inspector will use a Pythagorean triplet to check that the forms make a right angle. So first, the perpendicular sides are marked at selected lengths. Then the diagonal distance between the marks is checked to make sure that it is a Pythagorean triplet. So what they're doing is when they're making this, they need to make sure that this is a 90-degree angle, okay? Why can't they just use a protractor in it? Sometimes if it's set up for concrete or if it's set up in a way, they can't actually access this point anymore. And so what they do is they need to make sure it's 90 degrees because 90 degrees is very structurally important, okay? It helps to ensure the building is the stress is in the right point. So they can use a Pythagorean triplet to actually make sure that it is in fact a right angle, and as long as everything works out, then they are good. And they can pour the concrete. Okay. So here you can see, okay, from here to here, that's 5 inches, which means from here to here, this must be 4, and this must be, or this must be 3, and this must be 4. Okay. Let's go to the actual work. Okay. Roof is being built over 24. Okay, so I got that. The slope of the roof is 4 inches 12. I don't know, 4 and 12. Okay. Calculate so that they're giving you a slope 4 over 12. I don't know why I said 4 in 12. That's not how I would do it. I would do 4 over 12. Or 4/12. Calculate the length of the rafter needed for the roof. Include 2 feet for the rafter tail. Okay, so you can use your Pythagorean theorem. 4 squared plus 12 squared equals whatever this is here. Okay. Include, you want the rafter tail. Okay, so that's important. Include 2 feet for the rafter tail. All right, so you add the 2 feet at the very end. Okay. Okay. So consider the length of the rafter to be the hypotenuse. You first find this length, and then you add 2 feet here. Okay, that's not too crazy. Pretty straightforward. Convert it to inches. All right, seems relatively straightforward. She knows how long her rope is over here. Sorry. She knows how long her rope is here. She can easily figure out the distance here, and then she can use that to figure out the height. Okay. So you can then figure out your missing height. Something that what you will do oftentimes is, I don't think that's important. I won't distract you. Let me do one of the practice sets to really give you guys some help with this. 12-foot ladder is leaning up against a building. Okay, so I already know if it's leaning up against a building, that's 12 feet. That's going to be my hypotenuse. The building is probably going to create a right angle somewhere with the ground, I would hope. The base of the ladder was 5 feet from the building. Okay, so how high up on the side of the ladder did the ladder reach? Okay, well, I gave you a help a little bit ago. Always look towards Pythagorean triplets, okay? Is there a triplet that we can use? You know, I like to check there first. It doesn't look like there is, so it means we're going to have to do some work here, right? Okay, so 5 squared plus b squared equals 12 squared, okay? 12 times 12 is 24 times 120, so 144. Okay. Over here, 5 squared is 25, and b squared continues to just b squared. Okay. I'm going to subtract 25 from both sides. Okay, it's going to give me 39. It's going to give me 119. So square root of 119 equals b. Okay. And now how do I solve the square root of 119? It looks like we can go ahead and use a calculator because we don't know the math on that. What they'll have you do later is they'll have you just leave it in square root and then just break it out. So you'll try and find any perfect squares that you can remove from there. So let's say it's 119. So you might see if 3 or any other numbers can come out of that. But let's just go ahead and do square root of 119. Throw it in your calculator. Square root 119 is 10.9. So B equals 10.9. Okay. All right. Okay, let's you should be able to solve the rest of it. The written practice, I'll go ahead and have you do let's do 17 through 30 all. 17 through 30 all. All right, guys, have a good one.